A multi-institutional study was done to evaluate the airflow characteristics of the Shikani speaking valve in different angle orientations and compare them to the Passy Muir valve, which is the most commonly used flapper valve on the market. The study was done in collaboration with researchers from the National Institute of Health and the University of South Florida, and it was published in the American Journal of Speech and Language Pathology, the leading U.S. peer-reviewed journal in the field of speech and language in the United States. Using a pneumo-thachometer, which acts as an artificial lung machine, the airflow and resistance characteristics of the Shikani speaking valve were measured at different flow amplitude and the different degrees orientations from the horizontal, both in the 6 o'clock and 12 o'clock configurations, and these were compared to the airflow and resistance characteristics of the Passy Muir valve. When the Shikani speaking valve was placed straight or at 0 degree from the horizontal, the valve demonstrated significantly lower airflow characteristics compared to the competitive Passy Muir flapper valve across all airflow amplitudes in the 6 o'clock and 12 o'clock configurations, in normal breathing and light daytime activities where the tracheotomized patients typically wear a speaking valve, which is between 0.1 and 0.3 liters per second. The statistical significance of the superiority of the Shikani speaking valve was confirmed across the board using an analysis of variance, or ANOVA. When the Shikani speaking valve was placed in the plus 20 degree position, which corresponds to the patient in the sitting or standing position, the valve also demonstrated significantly lower airflow resistance as compared to the competitive flapper valve across all airflow amplitude in the 6 o'clock and 12 o'clock configurations, in normal breathing and light daytime activities where the tracheotomized patient typically wear a speaking valve, which is between 0.1 and 0.3 liters per second. The statistical significance of the superiority of the Shikani speaking valve was also confirmed using an analysis of variance, or ANOVA. When the Shikani speaking valve was placed in the minus 15 degree position, which corresponds to the patient bending forward, the valve also demonstrated significantly lower airway resistance compared to the competitive Passy Muir flapper valve across all airflow amplitude in the 12 o'clock configuration, in normal breathing and light daytime activities where the tracheotomized patient typically wear a speaking valve, which is between 0.1 and 0.3 liters per second. In the 6 o'clock configuration, the airflow resistance of the ball valve approached that of the flapper valve at lower airflow amplitude, but then trended to decrease airflow resistance at higher airflow amplitude.